Hello class, I'm going to be showing you today how to use the melter block melting point apparatus. This is also known as the OptiMelt automated melting point system. Now this instrument is used to determine the melting point range of a sample. And I'm sure you know that the melting point can be used to determine the identity and the extent of purity of a substance. So to get started, the first thing you want to remember is that when doing melting points, you want to use a small amount of sample, because if you use a large amount of sample, it's going to take longer for the sample to melt. And so I have my sample in my hand here, and you can see I have a spatula also. So I'm just going to take a spatula tip of the sample like so and place it on a weighing paper. Okay, so I'm going to place the sample on the weighing paper like so. You can see I've placed the sample on the weighing paper like so. All right, so the next thing I'm going to do is I'm going to fold the weighing paper into two halves like so. I'm going to fold it like this. All right, and then I'm going to grab a capillary tube. This is what the capillary tube looks like. We'll grab the capillary tube, and then I'm going to gently guide the sample into the open end of the capillary tube. Once I guide the sample, I'm going to tap it on the bench, guide it some more, tap it on the bench, guide it some more, and I'm going to tap it on the bench like so. Okay, now when I'm done doing this, you'll see that I have been able to successfully put about 1/8 of the sample, of the solid sample, into the capillary tube. Okay, now at this point, if you look at the display, you'll see that there is a start temperature and there's a stop temperature. The start temperature is the temperature at which the metal block is going to start heating, right, itself, to go higher, right? And we always put the start temperature much lower than the melting point of the substance. Now, since I don't know the melting point of the substance, I can put the start temperature as low as possible. So in this case, I've set the start temperature, which is to about 50, okay? Because I know, of course, from experience, I know that this sample is going to melt maybe around 80 or higher, okay? And then I'm going to put the stop temperature, that's the temperature at which the metal block will stop heating. I'm going to put it at 130 because I want the stop temperature to be much higher than the melting point of this substance. So you see the 50 is less than the melting point of the substance, while the stop temperature, which is always higher than the melting point of the substance. Now, the next thing I'm going to do is I'm going to place the capillary tube into the into the sample compartment. Now we have 3 sample compartments. We have 1, 2, 3, right? So I'm going to place it in the center sample compartment like so. I'm going to place it in the center sample compartment. Okay. Now once I place it in the center campus compartment, then I'm ready to begin the melting point determination. And so what I'm going to do is I'm going to hit the start button. You can see the start button here. I'm going to hit the start button. And once I hit the start button, you're going to see 3 windows will come up. 1 window for the left sample, 1 window for the center sample, and 1 window for the right sample. I have put my sample in the middle or center compartment. And so I'm going to be looking at this center sample button. Okay? I'm going to be looking at this center. So using the center sample button, once I look through this magnifying glass and I see the first sign of the sample going from a solid to a liquid, then I'm going to press the center sample button, okay? And when I see the last bit of the sample become a liquid, completely become a liquid, in other words, the entire sample becomes a liquid, I'm going to press the center button again, okay? That's because, remember, the melting point is always reported as a range, the start melting point and the stop melting point, okay? All right. So right now the temperature is at 62.4. So we're going to wait for it to climb. I'll keep looking through the magnifying glass at the same time to ensure that the sample has not started melting. You can see just by looking through the magnifying glass, I can see that the sample is still a solid. So we are still okay. All right. So we're going to wait for the temperature to climb. So the temperature has risen to 80.6 degrees right now, but I can see that the sample is still a solid. When I look through this magnifying glass here, I can see that the sample is still a solid. And so I'm just going to keep observing the sample. Immediately I see the first sign of the solid becoming a liquid, I'm going to press that center button. Okay? So I'm looking at the sample through the magnifying glass. We're at 85 degrees, 85.3, 6. Now we see that the sample, I can see that the sample has started melting. So I'm going to press that center button. And I keep observing. You can see that the sample is still melting. It's still melting. I want to press the button again when I see that the sample, the solid has entirely become a liquid. It has entirely become a liquid. And so I can see it has entirely become a liquid, so I'm going to press it again. All right, so I'm done. I'm done. So I'm just going to hit halt. I'm going to press halt because I have pressed the button when I saw the solid becoming a liquid, and I pressed the button again when the last bit of the solid sample became a liquid. And so as I'm done, I'm now going to halt the whole process. I'm done. So I'm going to press this I'm going to press this report button. You can see this report button here. When you press this report button, it will tell you. Okay, so I recorded 86.5 to 90.7. The camera, right, reported 86.0 to 91.6. All right, so I mean that's pretty close, but remember the camera is definitely it's going to be more accurate than I am, right? Okay, so you can just report that which the camera has shown, but at least you have an idea of when you saw the sample begin to melt and when you saw the sample stop melting. All right, so that is how we determine the melting point of an unknown solid using the OptiMelt or Metablock apparatus. See you soon.